Hello, my name is Ishwar and today I am going to explain about Fourier transform and Fourier series. The Fourier transform and Fourier series are a useful tool which is used by many engineers nowadays. The Fourier transform and Fourier series are developed by none other than Fourier himself. The Fourier transform is a tool which breaks the waveform into many alternative representations and characterizes into cosine waves and sine waves. By varying frequencies, the Fourier transform shows that any form can be written as the sinusoidals. If you know nothing about Fourier transform, start by introducing link to the left. If you want to brush up the check Fourier transform, the Fourier transform is simple as this one is simple as this is the equation for the Fourier transform. This is the equation for the Fourier transform, which generates cosine and sine waves. The Fourier transform is a mathematical tool which converts the signal from the time domain to frequency domain. The Fourier transform has many view applications, and the periodic signals are combined to form the Fourier transform. The Fourier series break down the periodic signal into sinusoidal waves, and the Fourier transform, which has the fundamental period of 2 into t. The convergence of Fourier transform. The Fourier transform is over a period. It has absolute integrability. In condition 2, it has an infinite interval and is out of bound. And the condition 3 is it has finite interval. There are only finite number of discontinuities. Further, each of the discontinuities are infinite. Then the Fourier transform to the Fourier series. Now let us see how Fourier series to Fourier transform is applied. For the periodic signal, we can represent them into linear harmonics, and to extend this to non-periodic signals, we need to consider an aperiodic signals as the periodic signal with infinite period. As the period becomes infinite, the corresponding frequency components form a continuum, and the frequency series sums become an integral or derivation of the continuous time signal. The definition of Fourier transform is as follows, which convert it into frequency domain. Now let us see an example for the frequency transform of decaying signal. When we apply Fourier transform for the decaying signal, we can see it has converted into 1 by a plus j, which is this signal, and to a rectangular signal it is converted into a sinc function we can see here, and impulse signal, all frequencies are combined to one frequency. And the examples of the periodic signals are simple examples for the periodic signals are sinusoidal signals and periodic train pulses, impulse signal. Now let us recap again how the Fourier transform is applied. The Fourier transform is simply a mathematical tool. The Fourier transform decomposes any functional frequencies into sum of sinusoidal waves. Each of these basis function complex exponential of the component of the different frequencies. The Fourier transform therefore gives us a unique way of viewing any function as the sum of simple sinusoidals. The Fourier series shows how to rewrite a periodic signals into sum of sinusoidals. The Fourier transform is an extension of idea of non-periodic functions. The introduction to Fourier series breaks down a periodic function into the sum of sinusoidal function. It is a Fourier transform for the periodic function to start the analyzing of the Fourier series, and is defined by the periodic function and is fundamental to the P. And these are the different convergence of the Fourier transforms. And the Fourier transform, this is the different periodic and non-periodic signals which can be applied. And Fourier transform can also be called as the synthesizing and the analyzing of the Fourier transform. This is the decaying signal, how the Fourier transform is applied. And to singular rectangular signal, this is how the Fourier transform is applied. And this is the impulse signal which converts into one and this is the corresponding signal which is more general and complex. Summary: the Fourier transform and Fourier series is used to represent the periodic and aperiodic non-periodic signals in frequency domain respectively. Looking at the signals in frequency domain allows us to understand the frequency response of a system and also to design systems with a particular frequency response, such as filtering out high frequency signals. You need to complete the exercises. Thank you.